Hi, everyone. Today we're going to be talking about our first topic in chemistry part A, which is going to be matter. So we're going to be defining chemistry, defining matter, defining what we call substances or pure substances, and then how do we actually categorize matter from there. So chemistry is the study of what matter is and how it can change from material to material and essentially account for everything that we have in the universe. The matter that exists in the universe is the matter that will always exist in the universe, and it just changes what it is to a different form of matter. So in chemistry, we have a lot of different branches, you could say, where they're focusing on different components of how that matter changes. So something like organic chemistry might study plastics, pharmaceuticals. They're who are working at synthesizing new things that haven't quite existed yet and trying to figure out how we can manipulate those atoms and those molecules to make substances that do what we want them to do. We essentially design them. And yeah, as you can see some other examples, there's a lot of different ways that chemistry is applied to our everyday life where we might not really realize that what we're observing and what we're experiencing is chemistry at its root. So matter itself, chemistry is the study of matter, and matter is anything that has mass and takes up space. So when we're measuring matter, we measure it through its mass. How many particles are inside of that object? How much matter does it have? And matter can be particles, atoms, anything that's, necessarily small, but it has to have mass and has to take up space. So in theory, an atom of hydrogen is matter because it has mass, even though it's really little, and it takes up space, even though it's really little. So even then, something is matter all the way down to that level. It just has to have mass and take up some space. We do, however, want to designate that mass is different from weight. While mass is looking at how much matter something has, weight is looking at that matter and how gravity is pulling on it. So gravity is totally dependent of the size object you're standing on. So if we're standing on Earth, even though my mass is 63 kilograms, that's a weight of 140 pounds based on Earth's gravitational pull. A much smaller object like the moon has much less gravitational pull. So even though my mass stays constant throughout the entire universe, I still have the same exact number of particles that I've always had. My weight is going to change because weight is dependent on gravitational pull. The bigger the object, like the bigger the planet, or perhaps celestial body like the sun, the higher the weight, but the mass is constant, as you can see in this example here. So when we're talking about substances, a more descriptive term is what we call pure substances. It's something that has a uniform composition. It doesn't change throughout its composition. It's the exact same particle over and over and over and over again. Whether that particle be an atom, a molecule, a macromolecule, if it's a pure substance, it's the exact same thing throughout. So if we're looking at something like table salt, which is sodium and chlorine bonded together to make sodium chloride, that's considered a pure substance. No matter where I look in the sample of table salt, every single one of those crystals is going to have the exact same atom combination present, the one sodium and the one chlorine. If I look at water, that's also a pure substance. If I'm, getting water from my deionized water, pure water, it has two hydrogen atoms and one oxygen atom. That makes H2O. No matter where I look in that sample, every molecule is going to be H2O. But something like seawater isn't pure. Different locations are going to have different salinities, which is different concentration of salt. And that's a different composition. It's not uniform throughout. So that would not be a pure substance. So looking at chemistry, we're looking at how these pure substances evolve from one thing to another and how they combine at that atomic or that molecular level. So when we're looking at properties of matter, I'm going to hide that real quick. When we're looking at properties of matter, it's really important that we're able to at least categorize them somewhat, because remember, matter is everything in the universe that has mass and take up space. So that's a lot of stuff. And as humans, we tend to categorize things based on what we can observe. So physical properties are things that we can observe or we can measure without changing what the object is. So by me observing it, I'm not impacting it in any way. I'm simply just observing it. So for example, freezing something is an example of a physical property, the temperature at which something freezes. By me freezing water or freezing any substance, all I'm doing is changing it from a liquid to a solid. I'm causing those particles to slow down their movement and eventually get into a fixed position that's frozen, that's a solid. But the molecules themselves are still the same atoms combined together. So if we're looking at water in this example, even though it's frozen, it's still two hydrogens and one oxygen. It's always going to be that combination. So things that are typical physical properties of matter, things that I can observe without changing the substance, are density, color, odor, what smell something has, how something tastes. Even though we don't taste things in chemistry, that is an observation that could be made about something. Its hardness. So how hard is it when I apply pressure to it? What's its melting point? What's its boiling point? What's its freezing point? So when you're trying to evaluate whether or not something is a physical property, ask yourself, does me observing this change the substance? Okay. If it does, that means we have what's called a chemical property. A chemical property is a ability or inability for something to react and change into something else. So the result of observing a chemical property is a permanent chemical change. For example, if I want to see whether or not something can rust or corrode, that's the proper term for it, I have to actually expose that object to oxygen. And in the process of it corroding or it rusting, it's going to form something new, iron oxide, which is much different than iron itself. So if you've ever felt rust before, you know that it feels very like brittle, crumbly, whereas iron is very flexible, very strong, very malleable, much different properties. So me observing its ability to corrode is going to cause a permanent chemical change. So things that will also be considered chemical properties, whether or not something is flammable, whether or not something's corrosive, whether or not something is reactive, so whether it can react with one thing or another. All of those, in order for me to observe that property, I have to cause it to change permanently. I'm not going to be able to change it back. One thing that sometimes can be a misconception is, what about conductivity, whether or not something can conduct electricity? When you apply an electrical current to something, all you're doing is allowing electrons to try to flow through it. So something like a metal is very conductive of those electrons to move. So metals tend to conduct electricity quite well. So because me conducting that electricity doesn't change the object itself, that's actually going to fall under a physical property. So it's not listed here as an example, but you might want to add that here as one, because that can sometimes be a little bit confusing. But there is no change that takes place. And think about it like this: you turn the lights on and off in your home every day, and your wires aren't breaking down and forming some new substance every time you turn the lights on and off, right? So it maintains that same, characteristic that it had because it hasn't changed. So the other thing that we talk about with this are intensive and extensive properties. For both of these, we're looking at properties that either depend on how much is there or don't depend on how much is there. So if you're trying to determine whether or not something like color is an intensive or an extensive property, we're looking at sulfur. Doesn't matter how much sulfur we have, sulfur is going to be yellow. That's its color, okay? Regardless of the quantity I have, regardless of anything else. Its melting point. What temperature does sulfur go from a solid to a liquid? Doesn't matter how many sulfur atoms I have hanging around in the sample. The temperature that they go from a solid to a liquid is 115.2 degrees Celsius. That is constant. Doesn't matter how much I have. So we say it's independent. So I always try to remember intensive is independent. Doesn't matter how much is there. The other side of the coin is an extensive property. This does depend on how much is there. This is something like mass, which is directly correlated to how many particles are present. So the more particles, the higher the mass. Same thing with volume. The more particles in a sample, the bigger the volume. Length is another example of an extensive property. They're things that they're properties that are going to depend on how much substance that you're working with, okay? So again, I remember them. Intensive is independent. That's my kind of mnemonic way of remembering it. So let's do some practice real quick. We'll see if I can get my pen working here. When we're looking at how to describe characteristics that would make something a substance, or what we call, I'm going to add in this term here, a pure substance. Oh, that's terrible handwriting. Let's see if I can try that again. There we go. A pure substance. It needs to be uniform. And it needs to be the same particle. So we want to make sure those things are in place if we're talking about something being a pure substance. It's uniform, the exact same all around, and it's the same particle. So these ones we're going to be trying to categorize whether or not this is a chemical or a physical property based on what we read. So iron and oxygen form rust. If I see the term rust, if I see the term corrode, if I see any of those kind of like key phrases, that's my indication that this is a chemical property. So, oh gosh, I didn't want to do all that. Okay, well, okay, it's fine. So yeah, iron and oxygen forming rust, that's a chemical property. But the next one, iron is more dense than aluminum, that is a physical property. Density is a physical property. It doesn't change the substance if I'm measuring it. Magnesium burns brightly when ignited. This is also a chemical property. Again, we have that burns term, just like we have rust. That's an indicator that we are flaming something or, something that's flammable. And that's going to cause a permanent change. The next one, oil and water do not mix. This is called miscibility. This is a physical property, okay? If I mix together oil and water, I'm not changing the oil into something else, and I'm not changing the water into something else. They're both still the exact same thing. They're just in the same container, and they're not mixing together. And then finally, we have mercury melts at negative 39 degrees Celsius. So melting is a state change, and state changes and what temperature it melts at is physical, because even though if mercury is a solid or a liquid, it's still mercury. We're still going to be looking at the same atoms here, okay? In this third example, what it is that we're doing is we're identifying chemical and physical properties. So I'm going to do it as an underline. I think I was going to see if I had a highlighter, but I don't. So I'm going to do it as an underline. I'm going to make my physical properties this orange color and the chemical properties kind of this pinkish color, okay? So if you see me underlining things, that's why they're different colors. So bromine is a reddish brown liquid that boils at 59 degrees Celsius. Before I even move on, let's look at how this bromine is being described. It's being described as a reddish brown liquid. Me observing its color doesn't change it in any way. So this is going to be physical, okay? It also tells me that it boils at 59 degrees Celsius. That's also physical, okay? It doesn't matter how much of that bromine is present, and it's not going to change itself. Its boiling point is just changing it from a liquid to a gas. So again, it's not changing the atom itself, which makes it a physical change. Next, it says it's highly reactive with many metals. For example, it reacts with sodium to form a white solid. So here's kind of that key term again. We see highly reactive with many metals. That's a chemical property. Reactivity means that it wants to change into something else. So that is going to be a chemical change. So for example, it reacts with sodium to form a white solid. Again, that's a chemical property because it's undergoing that change in order for us to observe its reactivity. There are also some other practices with problems very much like number 3 that are posted on Google Classroom. So I would encourage you to take a look at those and use that as kind of like a basis for your studying purposes, because you want to make sure that you can identify both of these.